Hello and welcome to this session on creating a package. When your application gets to be so big that you want to organize your modules into separate folders, then you will need to create packages. The way that you create a package in Python is that you move your modules into separate subdirectories, and then in every subdirectory that is intended to be a package, you will need to include the init.py program inside every one of those subdirectories. So as you can see on the right, our folder S08-4 has subdirectories called labs, util, and dev class. And we have moved our modules for util and dev class into their appropriate folders. So we have readdevs and printdevs.py inside the util folder, and we have basedev, iosdev, and xrdev inside the dev class folder. In order for those folders to be considered packages, as you can see, we have created init.py Python application code, which can be, in fact, an empty file in each of these folders. This signifies to Python that this directory should be considered a package. Our main application, since it is not considered a package, happens to be in the labs folder. And since it's not considered a package and is not called from anywhere else, we do not need to have init.py in the labs folder. Hello and welcome to this session on separating your Python code into modules and also your modules into separate packages. If we look at the directory in which we have put our packages, you can see that we have our main program, which looks like it did before. And we also have now, instead of having modules, we have directories. One directory called util, one directory called dev class. What do those directories have in them? If I do a listing of dev class, then what we can see is that there are a number of Python modules inside it, and there's this one special module, which is a Python file called __init___.py. If you want your directory to be considered a Python package, then you need to have this file, a file with this name, in the directory. The file can have nothing in it. In fact, init.py here has nothing in it, but just its presence tells Python that this is actually a Python package. I've separated my old module, which in previous demos was called devclass.py, and I've separated into 3 separate files. So I've taken the base class and put it in basedev. I've taken the iOS class and put it in iOSdev. And I've taken the XR subclass and put it in XRDev. So I've actually separated things a little bit more. In the real situation, when you begin to have lots of code for different device types, then you will want to be separating your code into something that looks like this. What does the util directory look like? If we look at util, then you'll see, again, we have __init__.py. That will have to be there to tell Python this is a package. And I've taken my util.py and separated it into 2 separate files called printdev and readdevs.py. So I have actually 2 of these Python modules now that used to be in util. And in my dev class directory, I have separated devclass.py, which we used before, into 3 actual Python files, base class and iOSdev and XR. Let's take a look at these files. If I look at main, then my main application, if you look down here, it's going to look pretty much the same as we've always done before. I'm going to go read the device info, and I'm passing in the file name, and then I'm going to say for every single device in that list, do a device connect, do a device get interfaces, and then print information for that one device. Now the thing to note here is my import statements look a little bit different. Remember, there are 2 forms of an import statement. In one, you just say import and you specify the module name. In others, you can specify actually the function name. And in this situation, I have chosen to say from and given the module name and then specify the actual function name that we are going to be using. Now in this situation, you need to notice something different. Here we're saying this is actually the module name, and the module name needs to represent the directory path to get to readdevs. Remember over here, readdevs was in the directory called util. And so what I need to do with dot notation is specify to Python, you need to look in util. Actually, slash is where it will look, but we use dot notation in the code to readdevs, and it will look in this file called readdevs. This is my import statement in the main program. Now I'm going to exit this, and I'm going to go down into the util directory. And when I get here, remember I have init, and I have printdev, and I have readdevs. I'm going to look at readdevs and examine what this looks like. So looking at the code here, my code for readdevs looks exactly like code has looked before. I'm going to go through the file, the devices file. I'm going to look at every single line. I'm going to put the data from the line, the device information, into device info. At this point in time, I'm going to look at the actual OS type, and if it's iOS, I'm going to create an iOS device. If it's some other type of device, I don't really care about it because I'm actually only interested in iOS devices in my lab, and so I'm going to create this iOS device. Now again, we need to look at our import statements. Once again, I'm importing a specific function, or actually in this case it's a specific class from the module that we're going to look at. And here's my module that I'm specifying. Once again, I'm needing to specify the entire path in order to get to base dev or to iOS dev. And if you recall, when we looked at the dev class subdirectory, we have base dev, and we have iOS dev, and we have XR dev. So here I'm going to be getting access to network device class from base dev and to network device iOS from the iOS dev module. This is how you separate your code into not only modules but also packages in Python. This will be important for you to do as your application that's managing and controlling network devices begins to grow and you want to organize things into their own separate directories.